We're going to now look at some of the properties of the cross product. Most of them work at least in a similar fashion to what we've seen in other algebra. Although the first one, instead of the commutative property working, we have what's called an anti-commutative property, where we take the negative of the cross product if we do them in reverse order. The distributive property of the cross product works. It has to go in proper order. Again, the commutative is going to mess it up. And with the scalar multiplication, if we multiply by a scalar c, if we multiply it to a cross product, we either associate it with the first vector or the last vector. If there's multiples, you pick one. So you can place the constant in any one of the vectors of a cross product part, but it's got to be with one. If you take the cross product of a vector and the zero vector, you get 0 in either order. Negative 0 is still 0. Number 5, if you take the cross product of the vector with itself, you get the 0 vector. And in a subsequent video, we'll talk about why that is. And the last one, the scalar triple product. So this combines a dot product and a cross product. And the result that you get is that at the bottom. We're not going to cover that in this video, but we'll get to it later on. All right, so let's take a look at a problem. Actually, before we do, there's a few different things that we have for the unit vectors and cross products. So ij, jk, and then ki all will give you the third unit vector. So I cross j will get you the k vector. J cross k will get you the I vector, and k cross I will get you the j vector, and then the anti-commutative property works if you do them in the opposite order. And again, so we've got some dots here, we've got some x's here. These have both in past been used for multiplication. Neither is being done in this way. You've got a dot product and a cross product, so keep that in mind and be careful. All right, so let's do this problem number 188. We're going to simplify, and we're going to use these properties, and mostly we're going to use a lot of what's on the left here with these unit vectors, since all of these are in unit vector form. All right, so let's clean up the inner bit of this parentheses. I'm going to change it to a bracket because I may move stuff around. All right, k cross j, we note, is negative I. The 2 can come out, and j cross I, we note, is negative k. And this next bit, j cross j, we note, is 0, so this is just going to be plus 0. And the 5 can come out, but I cross k is negative j. So we have negative 5j here. So now we can do the distributive property with our vector j. So this is going to be negative j cross I. You can actually put it inside, put the negative in the j, doesn't matter. Negative 2 little j cross k. Again, the 2 can go wherever. I'm going to put parentheses around these. The 0 kills it, doesn't matter. And then we have negative 5j cross j. Well, this one, that goes away. That's 0. So j cross I is negative k. We have a negative in front, so we have negative k minus 2 times j cross h. Excuse me, j cross k, can't read my own writing, and that is I. So this should be negative 2I plus 0j plus k. We can write it like that, or we can also write it like negative 2, 0, and k. And you know the 0 in this form over here is superfluous. You don't really need it. But yeah, so this should be good. Either answer. And again, you don't have to have the 0j in the first.